All right, section 4.1, we are talking about linear functions. So we know that y is equal to f of x. Those two things mean the same thing. And we have worked extensively with linear equations, so like y equals mx plus b. If we replace y with f of x, then our linear equation magically becomes a linear function. And everything that we already know that is true about linear equations will be true about linear functions. So let's review just a little bit of some of the things that we know about linear equations and therefore linear functions. All right, so remember some of the formulas that we worked with back in section 2.2. These are actually the notes from 2.2. So slope is rise over run. We usually represent it with an m, and it's y2 minus y1 over x2 minus x1. Here's our point slope formula. So we use this when we have a point and a slope. Or this is our slope-intercept formula. We also can use that if we have a point and a slope to create the equation of our line. Now those two will not look the same unless we switch them over to standard form. And in standard form, you have ax plus by on one side, your constant on the other side, and you can have no fractions or decimals in here. So we have to have positive and negative whole numbers. So for this first one, they asked me to find my slope. So we're using our slope formula up here. I'm going to call this point 1 and this point 2. So this is x for point 1, y for point 1, x for point 2, y for point 2. So using that formula, I'm just going to say y2 minus y1, so negative 3 minus 4, over x2 minus x1, 2 minus a negative 5. So negative 3 minus 4 would be negative 7, and 2 minus a negative 5 would be 2 plus 5, or positive 7, so that would give us a slope of negative 1. All right, then they asked me to write the equation of the line in standard form, so here's our standard form again. That has a slope of 4 and passes through the point 1, 3. Okay, so let's start with y equals mx plus b, slope-intercept form. They just told me my slope was 4, so let's put 4 in for our slope right here. And then they told us that we had the point 1, 3, so we're going to put 1 in for x and 3 in for y. So 1 in for x and 3 in for y. And then you'll notice our only unknown is b, so that we can solve for it. So 4 times 1 is 4. Let's subtract that 4 from both sides, and we'll have b as negative 1. So for our equation, we can say y equals, what was m? Well, it was right here. It was 4. X plus, we just figured out that b was negative 1. And so that would be our equation in slope-intercept form. They asked us to give the answer in standard form. So in standard form, I need x and y on one side together. So I would need to subtract this 4x over. So you could say negative 4x plus y equals negative 1. If you looked in the solutions in the back of our book, they would probably write it this way because they don't ever like the leading coefficient to be negative. And so they would go through and multiply the whole thing by a negative 1. And so you also could write it this way. All right, now what if instead you had done that problem in slope-intercept form? I'm sorry, in point slope form. So y minus y1 equals m times x minus x1. Well, same thing. I would have put 4 in for my slope. I would have put 1 in for x1 and 3 in for y1. And this would have been my solution in point slope form. Now, if you'll notice, if I distribute that 4, so that would be 4x minus 4, and then I add this 3 over here to the other side, so 4x minus 4 plus 3, you'll notice that gives me y equals 4x minus 1. So the exact same thing that we got right up here, and then we could convert it to standard form the same way. So it doesn't matter if you use point slope form or slope-intercept form, you're going to get the same answer either way. All right, here's another one. So this next one says, create the equation of the line in standard form that passes through the points 1, 3, and 2, 7. So I have a point, I have 2 points actually, but I have a point. What do I need? Well, I need a slope because both of those equations, this one says point slope and this one says slope-intercept. So you need a slope. So I'm going to start off with doing y2 minus y1 over x2 minus x1, just like we did a moment ago. And so I would do y2 minus y1 over x2 minus x1. So 7 minus 3 over 2 minus 1. That would give me 4 over 1, or a slope of 4. And you'll notice that they just asked me the exact same question, just in a different way. Up here, they said you have a slope of 4 and you have the point 1,3. Down here, they gave me 2 points. One of them was also 1,3, and when we found the slope, it was 4. So you can see this is the exact same problem, just asked a different way, and it would have the same answer. All right, when we are graphing, again, remember that f of x is the same thing as y. So sometimes they might write it with a y, sometimes they might write it with an f of x, so same thing. So if we line this up here, you can see that 2/3 is in the place of m and -3 is in the place of b. So m is my slope and -3 is my y-intercept. Now, if I wanted to graph that, I'm going to start at the y-intercept. So I'm going to start at -3. And remember that slope is rise over run. So I'm going to rise 2, run 3, rise 2, run 3. And that would give me points. Now, you'll notice that positive 2 over 3 is the same thing as a -2 divided by -3. That would also be positive 2/3. So if you start here and you go a -2, so down 2, and a -3 back 3, you can see that's still another point on that same line. All right, let's do another one of those. So this guy over here, again, y is the same thing as f of x. So we can say -3/4 is in the place of m. And then over here, this would be plus 0. There's nothing being added to that -3/4 x. And so my y-intercept would be 0. So I'm going to start at 0. And I'm going to rise a -3 and run a positive 4. Now, when you're looking at that and going, wait, how did you know that that was a -3 over a positive 4 instead of a positive 3 over a -4? It's the same thing. So if I had come over here and I had risen a positive 3 and run a -4, again, that's going to be another point on that same line. So you can go both directions with that. All right, remember that the slope of every horizontal line is going to be 0. So when we talked about this before, we said you could kind of think of that as the bunny slope, or you could think of a protractor that you used in geometry to measure angles. That a horizontal line has 0 degrees of inclination, and slope measures your degrees of inclination. Something else is that every horizontal line will have the equation y equals some number. And the way we said that was easy to remember that is that when you have a horizontal line, it's going to cross over y, so it has to be y equals. All right, if you have a vertical line, when we talked about this before using that skiing analogy, we said that you cannot ski a vertical line. That's a cliff, right? And so that's not a slope, it's a cliff. So we could say no slope or undefined. Those are both the same thing. That is not the same thing as 0 slope. And then every vertical line will have the equation x equals some number, because again, if it's a vertical line, you can see it's going to cross over x. So without knowing that information, there is no way from this equation that you could get your slope and your y-intercept. I'm going to need to graph that and say, okay, x equals -2. That I know that x equals a number is always a vertical line, and it's crossing at -2. That's not a, you can't ski that. That's not a slope, that's a cliff. So that's no slope or undefined slope. And then what's its y-intercept? Where did it cross the y-axis? It didn't cross it anywhere, so I don't have one. All right, so then for this next guy, y equals 4. All right, so y equals 4 we know is going to be a horizontal line up here at 4, because it's got to cross y. So the slope of every horizontal line on the face of the earth is 0. And then where did it cross the y-axis? Its y-intercept, that would be right there at 4.